Alright class, today we're going to talk about probability of compound events. And we talk about probability all chapter here. Compound, you might have heard that word used in English, like a compound sentence is where and connects the two sentences. Kind of the same way with probability. We're looking for two things happening, something and something else. Alright, so a compound event consists of two or more simple events. So it could be three things we're looking for, or four, so at least two or more. What's the probability of someone winning their race in the third heat and being in lane 2? Okay, so we look at their probabilities individually and then we're going to combine them. How we combine them is based on whether it's independent or dependent. Okay, so independent event means the outcome of one does not influence the outcome of the second. Okay, so if I draw something out of hat A and I draw something out of hat B and I want to know what are the probabilities of drawing certain things, what I draw out of A does not affect B because they're separate hats. Okay, but if they're in the same hat and I pulled one out and then I took another one out without putting the first one back, that second probability is going to be different. Alright, that'd be a dependent event. We'll talk about that in a second. But independent means they're totally separate things. So if you have two separate piles, two separate die, two separate spinners, they're going to be independent. Alright, and so to find the probability of two independent events is multiplying those two probabilities together. So take the probability of A times the probability of B, whatever those two things are. So here our example is, the third heat, there's 1 out of 4 heats, times lane 2 is 1 out of 5 lanes. You multiply them, the probability is 1 out of 20. Alright, so here's another example of independent events. We have two spinners here. They're clearly independent. What I spin on this one does not affect what happens on this one. They aren't touching or anything. So if I spin the two spinners, I want to find the following situations. First, my final answer I want to find if both spinners are odds. Okay, so I got to find each individual answer and multiply them together. So what's the probability of the first spinner being odd? So here's your first spinner. I got 1, 2, 3 odds out of how many total? 5. So 3 out of 5 is my first probability. The second spinner being odd is 1, 2, 3 out of how many? 6. 3 out of 6 reduces down to 1/2. And so if I want to know if they're both going to be odd, what's that probability? If I spin them both and they're both odd, well, I need to multiply those two fractions together, and I get 3/10, or 3 out of 10. Alright, so that's how probability works of independent events. Here's a couple extra ones to just look at quickly. Probability of both showing a 2. Well, what's the probability of this one showing a 2? 1 out of 5. What's the probability of this one showing 2? 1 out of 6. So 1 out of 5 times 1 out of 6, multiplied together gives me 1 out of 30. Both are less than 4. Here there's 3 numbers that are less than 4, so 3 out of 5. Here there's 3 numbers less than 4, 3 out of 6. So that means it's 1/2. So give me the same answer as this one, 3/5 and times 1/2 is 3/10. Alright, so it's independent events, totally separate items, multiply them together. Dependent event. Now, this changes just because the second one is affected by the first one. So if you have a deck of cards and you draw a card out of it, the probability of getting a certain card on your second draw is different because there's one less card in the deck. Okay? Or if you have a jar full of marbles, different colors, you pull one out. If you pull another one out without putting that first one back, there's now less marbles in there, so the bottom number is going to change. Even the top number might change also, depending on what you drew in the first one. So if you have two dependent events, you take the probability of A times the probability of B after A happened. Okay, so what changed after A happened? So let's take a look at what this looks like. I have a bag. There are 3 blue, 7 red, and 5 white marbles. Once the marble is selected, it's not replaced. Once it's not replaced, that's your dead giveaway. That's dependent. Alright, we're not putting it back in there. Find the probability that 2 blue marbles are chosen. Alright, so if I want to draw that first blue marble, there are 3 blues in there. And out of how many total? Add them all up and you get 15. So 3 out of 15, which is really 1/5, I guess. Now, after I drew, let's say now I drew that first blue marble, what's the probability of drawing a second blue marble if I didn't put that back? Well, now how many blue marbles are left in that bag? Well, now there's only 2 blue marbles. And how many marbles total? 14, because there's 1 less total marble in there. So now it's 2 out of 14, which is 1/7. Okay, so I can reduce these down if I want to, 1/5 and 1/7. But either way, if I want to find the probability of them both happening, I need to multiply them. So 1/5 times 1/7 gives me 1/35. You see, by reducing right away, I get straight to my answer. Here, if you didn't reduce, you get this big number, and you have to reduce it all the way down to there. Alright? What's the probability of getting 2 white marbles? Well, getting a white marble is 5 out of 15, which is 1/3. I'll write that over here, 1/3. Times, now if I already drew a white one, I want another white one. There's 4 left. And now how many are left in the bag? Well, 14. So now there's less because I didn't put that one back. And that reduces down to 2/7. Alright, so my final answer would be 2 out of 21. Alright. And last guided practice, I want a red marble and then a white one. So pull a red one out. Well, that is 7 out of 15. There's 7 red out of 15 total. And now I want to pull a white one. So there's still 5 white ones in there. But now there's only 14 marbles in the bag. Alright. And I can kind of cross-reduce this if I want to make some smaller numbers. Remember how to do that. It should be 1 out of 6. Let's see if that's right. Boom. There it is. Alright. Now, one more thing we're going to talk about here is what's called mutually exclusive events. Those events are where they cannot happen at the same time. And we're looking for the word or. Or is kind of our dead giveaway to check out for these. Okay? If they're mutually exclusive, that means they cannot happen at the same time. Alright? That's like saying I want to roll an even number or a 5. Okay? Well, you can't roll both at the same time. You can't roll 5 and be even on one dice. So, these we're going to add. Okay? When you see the word or, we're going to add. Alright, so here they want to know the probability of spinning a 5 or an even. Well, in order to spin, spinning? Oh yeah, so the sum is both a 5 and even. Well, here are all the possible outcomes by spinning the spinner 2 times. Okay? I have one, I'll circle them. There's 1, 2, 3, 4 ways I can roll a 5 or spin a 5. Okay, so it's 4 out of 25. And then how many ways can I get an even number? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There's 13 ways to get an even number. So it's 13 out of 25. And I'm going to add these together. Okay, because they're mutually exclusive. The word or means to add. Alright. Teresa is playing a video game that involves rolling 2 dice. What's the probability that she'll roll a sum of 4 or a sum that is an odd number? So it can't be both. Okay. It's 4 or odd. Alright, so for rolling 2 dice, remember we make this chart with all the dice numbers 1, 2, 3, 4, 5, 6. And I go straight down 1, 2, 3, that's a horrible 2, 4, 5, 6. And now I look at all the possible sums. 1 and 1 gives me 2. 1 and 2 gives me 3. And then 4, and then 5, and then so on. Here I get 3, and then 4, and then 5, and so on. And then here I get 4, and 5, and 6. Okay? I keep filling out all this chart, but you can do that on your own. What's the probability of getting a 4? Well, I see 1, 2, 3 ways to get a 4. Okay? So 3 out of 36 total possible outcomes. How many ways can I get an odd? Well, if you fill out this chart and count them all up, there'll be 18 ways to get an odd number, 18 out of 36. So, if I add these together, because it's or, I'm going to add them, I get 21 out of 36, which reduces down to 7 out of 12. Alright. So that's how compound and mutually exclusive works. And we're adding when it says or, we're going to multiply the other ones. And just got to ask yourself, did the first event affect the second one? All right. Did spinning the first spinner affect the second spinner? No. Did pulling something out of a bag and not putting it back affect the second one? Yes. All right. So just keep an eye out for whether it's independent or dependent, whether that second number has to change or not. All right. Have a great day.